A single changed word in a prompt crashed production for 3 hours. Not a code bug, a prompt bug. Someone on the team tweaked analyze to evaluate in a customer support prompt, didn't test it, and suddenly the LLM started refusing to answer half the queries. This happens constantly in AI teams, and it happens because we're treating prompts like casual text files instead of versioned, tested, governed software artifacts. Today, I'm showing you how to build a prompt library that your entire team can trust. With Git-based version control, automated regression testing, and approval workflows that prevent exactly this kind of disaster. Here's how most teams manage prompts today. Sarah has her prompts in a Notion doc. Dev has his in a Python constants file. The production prompts? They're hard-coded in 3 different microservices. When something breaks, nobody knows which version is running where, who changed it, or why. This isn't a tooling problem, it's an architecture problem. We need to treat prompts as first-class software artifacts with their own repository, versioning scheme, and deployment pipeline. Here's what we're building instead: a centralized prompt registry, a single Git repository where every prompt lives as a versioned YAML file, a CI pipeline that tests prompts before they merge, a registry service that serves prompts to your applications via API, and a governance layer that tracks changes and enforces approvals. Let's build each piece. Every prompt in our library lives in a YAML file with a specific structure. The prompt itself is just one field. We also capture metadata that makes governance possible: the name and version for identification, a description so anyone can understand intent, tags for categorization, the owner who's responsible for this prompt, and input variables that define what dynamic data this prompt expects. This metadata is what transforms a random string into a manageable asset. Organization matters. Group prompts by domain, support, sales, internal tools. Within each domain, you might separate by use case or by product. The key is consistency. Every team member should know exactly where to find and where to add prompts. I also recommend a shared folder for common system prompts that multiple domains reuse. Prompts follow the same branching strategy as code. Main branch is production. Only tested, approved prompts live here. Feature branches for new prompts or major changes. And here's the key insight: use a consistent branch naming convention that includes the prompt name. When you see prompt, support, complaint response v3 in your PR list, you immediately know what's changing. No guessing, no digging through commit messages. Version your prompt semantically. Major.minor.patch. Patch versions for typo fixes and minor wording tweaks. Minor versions for adding new capabilities or input variables without breaking existing behavior. Major versions for breaking changes. Restructured outputs, remove variables, completely different behavior. Your applications pin to a major version, so they automatically get patches and minor improvements, but never break from unexpected changes. Your applications shouldn't read YAML files directly from the repo. They should fetch prompts from a registry service, a simple API that serves the right version of the right prompt. Here's a minimal implementation in TypeScript. The registry loads all prompts at startup, indexes them by name and version, and exposes a get endpoint. The key method is resolve version. When an app requests version 2.x, it returns the latest 2.xx patch. This is how you get automatic patches without breaking changes. On the application side, you call the registry with the prompt name and your acceptable version range. Here's what that looks like. The app requests complaint response with version care82, meaning any 2.x version. The registry returns the latest compatible version with a full prompt text. Your app then renders the template variables and sends it to the LLM. Clean separation. Your app code never contains prompt text. Here's the uncomfortable truth about prompt testing. You can't write unit tests that guarantee an LLM will behave correctly. Language models are probabilistic. But you can write tests that catch regressions, validate structure, and flag suspicious changes. Think of prompt tests as guardrails, not guarantees. We test three things: schema validation, regression, detection, and behavioral assertions. First layer, schema validation. Every prompt file must be valid YAML with all required fields. This catches malformed files before they ever hit production. Here's a simple test using Zod for schema validation. We define exactly what a valid prompt looks like and validate every YAML file against it. This runs in CI in under a second. Second layer, regression tests. For each prompt, we maintain a set of golden test cases, specific inputs, and their expected outputs from a known good version. When someone changes a prompt, we run the new version against these cases and compare outputs. We're not looking for exact matches. That's impossible with LLMs. We check semantic similarity using embeddings. If the new output diverges too much from the golden output, the test fails and forces a human review. Golden cases live alongside your prompts as JSON files. Each case has a unique ID, the input variables, and the expected output captured from a known good prompt version. When you make a major version bump, you regenerate the golden cases with the new expected behavior. This creates an audit trail. You can always see what the correct behavior was at any version. Third layer, behavioral assertions. These test for specific behaviors you always or never want. Does the prompt refuse to generate harmful content? Does it stay in character? Does it include required disclaimers? Here's a safety test that checks if customer-facing prompts properly refuse requests to share internal information. We send adversarial inputs and assert that certain patterns appear or don't appear in the output. Now let's wire everything into CI. This GitHub Actions workflow runs on every pull request to the prompts directory. First job, schema validation, runs instantly. Second job, regression tests, only if schema passes and only on change prompts to save API costs. Third job, safety tests on all customer-facing prompts. If any test fails, the PR can't merge. This is your safety net. Tests catch technical issues, but governance catches organizational issues. Who approved this change? Is it appropriate for the owner to modify this prompt? We enforce this with code owners. Any change to a production tagged prompt requires approval from the prompt governance team. Any change to customer-facing prompts needs product review. GitHub enforces this automatically. No approval, no merge. This is how you prevent that one word change from crashing production. Finally, every prompt needs a changelog. Not just Git history, a human-readable record of what changed and why. We enforce this with a pre-commit hook that checks if the changelog was updated when the prompt version changes. Here's a sample changelog. Notice each entry explains the reasoning, not just the diff. 6 months from now, someone will need to understand why you made that change. Make it easy for them. Let me give you a quick start checklist. Step 1. Create a dedicated Git repo for prompts. Step 2. Define your YAML schema with required metadata fields. Step 3. Set up schema validation tests. This takes 30 minutes. Step 4. Add code owners for approval workflows. Step 5. Build a simple registry service. Step 6. Add regression tests as you go. Start with your most critical prompts. You don't need all of this on day 1. Start with schema validation and code owners, then layer in testing as your library grows. Let's recap the 3 things you learned today. First, prompts are software artifacts. They need version control, schemas, and metadata just like code. Second, testing prompts is about regression detection and safety guardrails, not deterministic assertions. And third, governance isn't bureaucracy. It's how you prevent that one word change from causing a production incident. In the next video, we're going deeper into prompt testing. I'll show you how to build evaluation data sets and run A/B tests on prompt variants before deploying them. If you found this useful, subscribe and hit the bell so you don't miss it. Drop a comment below. What's your current biggest challenge with managing prompts across your team? I read every comment. See you in the next one.